All right, we're going to start today by finding 2 by 2 determinants. These are matrices, and we're going to find their determinant. Now, the main reason for determinants is to solve equations, like 2 by 2 equations. The two equations, two variables. So we'll start by showing you how to find determinants. Actually, really easy. Always start from the upper left and go diagonally down to the right. You are multiplying, like 4 times 7, that would be 28. And then you are subtracting, always subtract between them. And then you multiply diagonally from the upper right down to the left, so backwards. 2 times -3 is -6. The result is the determinant. Now in this case, negative is a positive, so 28 plus 6 would be 34. And that would be your determinant. In this case, 5 times -2 is -10. Now you could always have done this on your own and then check it. -3 times -1 is +3. The result is -13. And that's how you find a determinant. Now the next thing we're going to do is we're going to use determinants, and I'll have provided you with a worksheet with the details of this, but we're going to use determinants to solve systems of equations. Now the very first thing you have to do with determinants for this to work correctly is it must be the x term, the y term, the equal sign, and the constant. It has to be in that order. If it is not in that order, it will not work the way it's supposed to. So the first thing I'm going to do is I'm going to label each of these columns. I'm going to label this column A, this column B, and this column C. And that is going to be essential for us to be able to do this problem. So capital D for determinant is going to be a matrix or matrices where the first column is the coefficients in column A, and the second column is the coefficients from column B. Now, if we look at that, the coefficients here are 2 and 2, so 2, 2. The coefficients here are 3, and this is understood to be a 1. We do not include the variables in this. All right. So now we can do this simply. 2 minus 6, and that's -4. The next determinant is d sub x. Now you might be a little hesitant on this one as to what all that is. That means I'm going to replace the x column. It's still going to be AB, right? But I'm going to replace the x column, which is the A, with the answer column, which is C. So it's going to be C then B, not BC, C, B. Now when I fill that in, C is 5, 4, B is 3, 1. So I need to get the value of that. Let's give ourselves something. 5 minus 12. Now, 5 minus 12 is -7. Our next one, let's see, just double checking everything. D sub y, and D sub y, the y is going to replace, so it's going to be A and not B but C this time. So I'm going to fill it in. A is 2, 2, and C is 5, 4. So I'm going to get my answer here of 8 minus 10 or negative 2. All right. So here's my answers, because we need to know what x and y are. That's the whole point. X is going to be d sub x divided by d. In this case, d sub x is negative 7, d is negative 4, so the result here would be 7/4. Y is d sub y over d. D sub y happens to be negative 2, d is negative 4, so 2/4. So my final answer here, x is 7/4, y is 2/4. Well, 2/4 is much easier to write as 1/2, isn't it? So we'll say, I don't like that comma, let's fix that, 1/2. And there is your answer. You can see that the amount of work, now we'll do more of these examples, but you'll notice that the amount of work to do this problem, which was not a nice answer, is the same as the amount of work to get a nice answer. So if you're using one method and it's just not coming out very nice, this might be an easier method for a harder answered problem. Of course, you're not going to know ahead of time for the most part if it's going to be a harder answered problem. So this gives you, this method uses the same amount of effort, whether it's an easy or difficult solution. So all of these different methods that we've used, whether it's the graphing, substitution, linear combination, or determinants, they all have their pros and cons. Graphing, obviously, if it's an easy problem to graph, it's a good one to use. But for the most part, substitution and linear combination tend to be what most people use to solve systems. And then, of course, we have this one, which is also a really decent method. It just takes a little effort to write it out. This is already set up in our x, y equals number. And we know our A, B, and C. So D, determinant, is going to be your A column, 5, 2, your B column, 4, be careful, negative 1. I'm going to write all of them out. Your D sub x is going to be your 7, 8, your C column, and your B column, 4, negative 1. And your D sub y is going to be your X column, or 8, column 5, 2, and your answer column 7, 8. If you make a mistake in a particular value, you say you put a positive one, it is going to completely throw off your answer. So you really have to be careful with each of these to make sure you're doing it correctly. Negative 5 minus 8, negative 13. Negative 7 minus 32, negative 39. 40 minus 14, positive 26. Now, x is going to be d sub x, negative 39, over d, negative 13. A much nicer answer here, positive 3. Y, d sub y, 26, over d, negative 13, negative 2. So my final solution here, 3, negative 2. Now, just like before in our other systems of equations, we will substitute these back in just to make sure we have the correct answer. And you have to check both problems, equations, I should say, to make sure that the answer matches and works properly. If it doesn't, then you know you've made a mistake somewhere along the way or in your check. so you may want to go back through it. All right, let's take a look at our next example. Now, in this one, you can see these obviously are not listed in the correct order. So we're going to need to manipulate this. I'm going to bring the x over by minusing 4x from both sides, or subtracting 4x from both sides. So that gives me negative 4x plus 3y equals negative 26. And then I'm going to need to move the 4y over. And that gives me, remember you want the x first, so negative 5x, negative 4y, and 14. Now some of these numbers could get rather large, so you have to be prepared for that. D, in this case, is negative 4, negative 5, and 3, negative 4. D sub x, negative 26, 14. Make sure you're leaving enough space to be obvious here. 3, negative 4. You don't want to think of negative 2, 6, 1, 4, all right? So be careful of that. And then finally here, d sub y. Let's see, negative 4, negative 5, negative 26, 14. All right, let's do these out. 16 minus negative 15. So it's plus positive, that'd be 31. All right, down here, let's see, 26 times 4, 104, minus 42. 62. And finally, let's see. Let's see, 4 times 14, 40, 56, negative 56 minus 130. So that would give me 186. Okay. It's negative 186, by the way. Got my negative sign. Negative 186. That's much better. All right. Now we need our d sub x, d sub y, and d. There they are. So x is going to be 62 over 31, or 2. Y is going to be negative 186 over 31, which is negative 6. So our final answer here is 2, negative 6. Again, plug them back into the original, not your adjusted one, but the original, and check to make sure that it all works out. All right, let's continue. Now, hopefully with you in class, we can talk about what terms are in math, and I don't mean vocabulary terms, I mean terms of a polynomial. So terms, a number, variable or variables, or a combination of a number and variable or variables, and those variables could be to a power. That's what a term is. Now, like terms, some of you may already know these, but like terms are terms that have the same variables with matching exponents. Okay. So, let's do these one at a time. 4x, 6x. Would those be like terms or not like terms? Yes or no? Yes, they are like terms. Those are definitely like terms. The variable has the same exponent. The coefficient is not important in determining like terms. All right, what do you think? These are like terms. The variable x has a 2 for an exponent, the variable y has a 1. Just because they're not in the same order makes no difference. Remember, a term with multiplication, because there's multiplication between these, need not be in the same order. All right, let's continue. How about those two? What do you think? The answer is yes, because these are constant terms. They do not include a variable. Constant terms do have the same, are like terms, I should say. And how about this one? And in this one, when you look carefully, x has the same exponent, y has the same exponent, z's here, but it's not here, so that's a no. They have to have the same variables with matching exponents for those variables. Finally, this one. Well, they both have the same variable, but x is not the same exponent for both of them. This one, x has a 2 and a 1, so that's a no. You can only combine like terms with addition or subtraction. You can't combine them if they're not like terms. Okay, so combining like terms. Here's a quick example of combining like terms. I usually go through them and do it in descending order by the exponent, unless there's multiple variables. Then it does not really matter which one comes first for the most part. So I go by the biggest exponent term, and that is here. The biggest exponent is a 3, and so I'm going to write down 4x to the third, since there are no other x to the third powers. Then I'm going to look for the next smallest exponent, which happens to be the 2, negative 3x squared. That's all one term. The negative goes with it. Positive 8x squared. When I combine negative 3x squared and positive 8x squared, that makes positive 5x squared. You do not change the exponent when you add or subtract. Next one would be the x to the first. I've got positive 2